Our next speaker is Dave Levine. He is the Science and Engineering Manager for the V&V Shared Services team at IDEXX in Westbrook. He's worked there over 16 years, developing, designing, and executing the validation and verification protocols for new parts, products, and process changes before they enter production. Dave graduated from WPI, and I still talk to him, so that's pretty good. With a Bachelor of Science in Manufacturing Systems Engineering, and he later received a Master's of Science in Instructional Design and Technology from Walden University. Dave has had a wide-ranging career in various low, medium, and high-volume manufacturing industries, from building satellites, wire bonders for the semiconductor industry, steering and suspension components for automobiles, luxury yachts, and now diagnostic tests and instruments for veterinarians. As an aside, Dave has been a long-time participant with the festival. We roped him in, I want to say 2016, 2017, like with a hands-on area at IDEXX, and we've had him ever since in various ways. So thank you. Dave's favorite, he's a big fan of how it's made at Nova, and I'm just going to quote you here. Mm-hmm. But when I was a kid, Bill Nye the Science Guy was must-see TV for me. And Dave's talk is designing effective validations through change effect assessments.
All right. Ready for this? All right? Yep. All right. I'm starting here. You know Theranos. You might know Elizabeth Holmes. And yes, I'm happy she's in jail. So basically, if you don't know the story of Theranos, the product development team identified a lot of problems with their instrument, but management decided to release it to the world anyway, which put a lot of people at risk. My job is to make sure stuff like this does not happen. So what is a CEA? What is a change effect assessment? Anytime we make a change to a part or a process, we got to validate it to make sure we didn't break anything. And we want to make sure our customers always receive the same thing. So this is just a systematic way to create and design test procedures to make sure we're looking at the right thing. We want to create focused test plans instead of testing everything. There's just too much that we can test for a change. And the goal here is to find any unintended consequences, meaning anything that we didn't expect to happen, we're going to look to try to find it happening. A lot of people are going to throw out red flags. Don't listen to the noise. The goal here is to always protect you, the customer. Now, what we're going to talk about is a change assessment that I did for the foil for a snap device. But you don't know what a snap device is. You do know what a candy bar is. And this is exactly the same process, so bear with me. We're going to start at the beginning, and you're going to answer the 5 W's. Don't worry about how at this point. We're going to get to that in another 3.5 minutes. What is changing? Figure out why we're doing it and identify a team. Yes, this is a team sport. This is not something one person can do. Draw pictures. Figure out what the process is and draw the process of the wrap going around the candy bar and how it holds in all that chocolatey goodness. Figure out why we have a wrapper. Well, it identifies stuff. It keeps it fresh. That's what you're going to do here. We're going to take those pre-pictures that you just made and put them into what we call a process matrix. And this is basically taking those functions, identifying the inputs, like the wrapper, the automation, the temperature and time and things like that, and figure out what happens. Well, it's wrapped. It doesn't have any holes in it. It prevents moisture from going through. We get to the meat and potatoes of the change assessment. This is a long process, but the first 2 columns, cut and paste. Where could things go wrong? Well, we just identified that. We know our functions. We know what happens. We're going to try to ask the question, what could possibly go wrong? These are our potential failure modes. We're going to look for potential failure modes for each individual output. Each one, you're going to go step by step. Then ask what happens when something goes wrong. What happens when it breaks? Does this open up? Does it get dirty? A severity scale of 1 to 5, so we know how bad it gets. We're going to look for potential causes. Why did it happen? And then we can get to the how. The how is your test plan. This is the structured test plan that we designed. This is the whole change assessment for the foil. It's big. This is small compared to some of the other ones. This took 2.5 weeks to go through. I did it in about 30 seconds. So yeah, it's a lot of work for a team. So it took about 2.5 weeks to get through all this. Now it's time to execute that test plan. That test plan that you came up with, now we do it. And there's really 3 results that can come from it. First, it passes. It meets all our acceptance criteria. Everybody's happy. We can release it to the field and you can eat candy bar. Might not pass. That's good. That's actually successful, because what I was able to do is find out anything that can go wrong with this and prevent it from getting to you, the customer, right? I want to make sure it doesn't get to you. The last thing is a failure. I've done hundreds of change assessments in my life, and I've only failed once. I looked at this thing and I figured out, oh, it wraps it well, the seal is nice and strong, there's no humidity going through, it runs through the machines perfectly, no problem. Yeah, it was a problem. What do you have to do to this when the customer gets it? Open it. I forgot to test that it could open. Fortunately, when we were running this experiment, we stumbled across it and I prevented it from getting there. We just lost a week's time. So that's why I do change assessments, and that's why I have a job, and that's why I don't like Elizabeth at home. Thank you.
I feel like I see a lot of recalls, especially for children's things, like risk of death. So like, what went wrong there?
So recall, so again, with this change assessment, and hold on, wait a second. Yay. Make sure it opens first. So with recalls, what they do is, we do change assessments, and remember, I missed something during that whole change assessment, and that's essentially what happens with a recall. They find something that through a lot of testing and a lot of cycles and a lot of things out in the field, they can notice something. When we do our testing, and I said we do focus testing, we try to create a sample size that will give us some sort of idea of a defect rate. So we identify a defect rate that we're looking for, and that's the sample size. As that sample size gets bigger and bigger and bigger, that probability shrinks and shrinks and shrinks. So when you throw stuff out in the field, especially with automobiles where there's millions of cars out there, that's millions of opportunities for a failure to happen. So there is some risk no matter what I'm doing, but that's why we try to create structured tests with the right sample size.
What was your most spectacular fail?
That was my most spectacular fail. Yes, that was my only fail. I've had a lot of them that don't pass. I've had a lot that don't pass. And the reason they don't pass is because I found that problem. And that was my goal, is to find a problem. When I'm presenting to the review boards, I don't care if the data meets the acceptance criteria or not. I care that I did the experiments right, I did the right tests, I looked for the right stuff, and I found whatever it was. If it doesn't pass, we can go back to the vendor, talk to them about the foil. So in this case, the foil was delaminating, meaning it was kind of peeling apart before you could peel open it up itself. So we went back to them, we figured out what was wrong with it. They made us a new batch of foil. We retested it through the validation. We didn't have to do everything in the validation because some of the things that we were testing to change didn't change for the second change. A lot of changing here, but we only tested what we needed to. So again, focus testing. We found out that it worked this time and we were able to release it.
How's your grocery shopping looking?
I hate it. When I go and get a bag of chips, I look at that bag of chips and I don't care what's in it. I look at the seams, I look at the platen on the back. It's like the print doesn't line up. It just bothers me. That's my life now. That's what I do.
Is this type of assessment transferable to non-technical things like app development?
Absolutely, yeah. So I am more of a mechanical guy. As an engineer, I don't drive the cool trains, but I'm a mechanical dude. We do this for the science-based stuff, the biologics, the actual assay itself that we run, the test itself. We do this on that too. So it's applicable to any change that you make. All you have to do is walk through it. Now your process map might look a little different. Your product map would definitely look a little different, but you can still do it and apply all the same techniques. This class is this is a 2-day, 16-hour class that we have at IDEXX to teach all this. And it's taken me years to get good at it and lead this. So at the beginning, you just kind of be a member of the team. Now now I can actually lead these things.
Right. When you have a change of vendor for a critical component, do you go through this process all over again?
Yep, for everything. Absolutely, we do it for every change. But the good thing is now my wife is going to kill me because she's a librarian, but plagiarism is great here. I fully endorse plagiarism. I have reused change assessments or basis of change assessments all the time, because why reinvent the wheel? Take something that's out there, take it, start from the beginning again, but a lot of it can be used. So we reuse it over and over and over. So yeah, change of vendor, that's exactly what this was. We changed vendors for the foil.
Dave's off the hook.
Thank you.